All right, everyone, we are going to go ahead and get started here. Thank you for choosing to spend your valuable time with us. Today's webinar will cover cybersecurity solutions for the satellite industry, presented by software engineer Jim. My name is Emma, and I will be moderating the webinar. All attendees will be in listen-only mode. If you have questions, please use the Q&A box. After the presentation, Jim and Anthony, our post-quantum specialist, will answer your questions. As always, our webinars are recorded and made available on our YouTube channel. If you'd like to stay updated with the latest from wolfSSL, follow us on X, connect with us on LinkedIn, and subscribe to our YouTube channel. Feel free to contact us via email at facts@wolfssl.com if you have any further questions. Before we dive into the technical presentation, I'd like to provide a brief overview of wolfSSL. Today, wolfSSL secures over 5 billion connections. We have more than 2,700 OEM customers and dozens of resellers. wolfSSL consists of over 50 dedicated employees, primarily engineers. This progress is, of course, supported by a strong partner network that we are very proud of. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO178 support, a FIPS 140-3 certification, and a FIPS-ready offering, MQTT up to the V5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfBoot, Java wrappers and JSC support, and commercial support for curl, and our newest product offering, wolfHSM. These offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full-service consulting. Now I'd like to turn it over to Jim to discuss cybersecurity solutions for the satellite industry.
Hello and welcome. Thanks everyone for attending our webinar today. I'll be discussing some of the solutions that wolfSSL has for the satellite industry. Although our focus is on satellites and related technology, the solutions really apply to many other industries as well. So let's get started. So our objective today, we'll learn more about wolfSSL and the libraries that are trusted by commercial, industrial, and military organizations. As some of you know, we're already in orbit providing satellite solutions. We'll review some of the aspects of the threat model and some of the ways wolfSSL can help with mitigations. I'll cover post-quantum, what that means for embedded devices and the solutions available. And we'll see why wolfSSL is the leader in cryptographic solutions and why so many organizations have chosen wolfSSL for mission-critical applications. So wolfSSL, it's both the name of the company and the name of the core library. In short, open source cybersecurity. The SSL refers to the secure sockets layer commonly used in internet communications. Typically, TLS is the cryptographic protocol used. Others might be IPsec, SSH, QUIC, and we even support encrypted UDP packets with DTLS. Some of the key features are, of course, the tiny footprint, all the latest algorithms, and really important, FIPS 140-3 certification. Most importantly, support. We have engineers available 24/7. The really cool thing is there's an ecosystem, a community are vibrant. There's an active support forum and continual updates on GitHub. So wolfSSL, it's a company with headquarters in the United States, specifically shown here in Edmonds, Washington State, just north of Seattle. The team consists of some of the world's most talented engineers based in countries all over the world. So most of you in the audience are in vertical companies. You'll have a special focus with a specific goal. wolfSSL is a horizontal company already providing robust security solutions to all of these industries and more. Some companies, such as ExpressVPN and iGel, are proud to announce that they use wolfSSL in their products. Others prefer to keep a low profile. It's your choice. So we already have satellite customers. In fact, wolfSSL has been in space for years. As a matter of fact, wolfSSL has been around for decades. Being open source and well-known, we've had the benefit of many researchers, PhD candidates, and others review the security of our code. It's all out there for anyone to. The company started out as an SSL library for MySQL. Today, it helps secure billions of connections in medical, aerospace, and consumer products. So these are the three areas of focus for the company. So data at rest, that's ensuring something like configuration files on your computer cannot be accessed if the hard drive is stolen. The data in transit, for example, ensuring that communications from ground stations to satellites cannot be intercepted or spoofed. TLS is a common protocol, and TCP It's the most common transport, but really wolfSSL works with many protocols and many transports. For satellite applications, something like DTLS may be of interest. In this case, TLS over unreliable UDP datagrams. But again, nearly any transport mechanism will work. And the last there is firmware upgrades. This ensures the integrity and authenticity of firmware. For example, when you deploy new software to an orbiting device. So today we'll discuss the importance of post-quantum and the risks when not using it. For instance, if someone determines your TLS key, recorded data can be compromised. This problem here is the harvest now, decrypt later risk. And the other one is if someone determines your firmware signing key, so malicious software could be deployed. This is your sign now, forge later risk. So here's an overview of our product line. At the core, you see there is wolfSSL, the main library. The cryptographic libraries are implemented in wolfCrypt. Together, wolfSSL and wolfCrypt are the core libraries used in other libraries in your project. Some of the products of interest to the satellite industry are the SSH, TPM, and MQTT libraries, among others. You can see there are a variety of other solutions, all have worked together seamlessly. There's a full TLS stack, again, that works with nearly any transport. We have nearly every cipher suite, and in particular, of course, post-quantum, and also SM, the Shangmi ciphers if you're doing business in China. You'll see the boxes across the bottom here. Those are some of the wrappers we have for Java, C#, Python, and so on. So a couple of notes for the developers in the audience. If you'd like to get started, and maybe you don't yet have or don't want to experiment on actual satellite hardware, wolfSSL products can be used on nearly any hardware in all the mainstream development environments. There's even a specific Arduino library that's typically published a short time after each wolfSSL release. It includes some basic examples such as a TLS server and a client. Nearly all of the Arduino boards will work. For TLS, you'll probably want a board with at least 32K of RAM, as there's a bit of overhead for Arduino itself. So more details on getting started can be found at the link you see there on the slide, and we'll see more details later on. Okay, so back to the wolfSSL overview. All the products have a dual license. It's all open source on GitHub. It's version GPL v3. There's also a commercial version with a proprietary license when you need to close source your project. So again, we have engineers all over the world with 24/7 support available. So being FIPS certified gives you the confidence to know that the cryptographic libraries have been exhaustively tested and validated by a qualified third party. In many cases, FIPS certifications will be a requirement, particularly if you are to or on a joint mission with the United States. FIPS 140-3 is a topic worthy of an entire presentation. We have both YouTube videos and online documentation that goes into much more detail on FIPS 140-3. Many of you are probably already familiar with the CNSA timeline. These are international guidelines, not just for the United States. We see here that the software signing is a requirement this year. wolfSSL is helping many of our customers with meeting these requirements shown here. wolfSSL has been in space for many years. We already have customers in the sky and in ground stations. And not only do we have solutions for the rocket delivery system, but we're also DO 178 Human Safety Critical Certified. The team at wolfSSL is collaborating with a variety of industry leaders. Here's an article from Embedded Computing Design earlier this year. In this case, there's an Intel Core i7 processor, the Curtiss-Wright VPX3 ruggedized single-board computer, running Cisco's PikeOS RTOS. Here the solution is using the wolfBoot secure bootloader, featuring the wolfCrypt cryptographic library. And so for satellites, performance is of course going to be key. So let's check out what HA Proxy had to say about the state of SSL stacks. You'll see there's a link to their blog there. These are the folks that provide some of the world's best load balancers and content delivery networks. So they really know what it means to have the best possible TLS and encryption libraries. So in light blue at the top, we're seeing the latest version of AWS-LC. The second fastest library in orange was wolfSSL. LibreSSL, well, that's a fork of OpenSSL. BoringSSL, that's also a fork of OpenSSL. AWLC, that's based on BoringSSL and by extension OpenSSL. And so let's take a quick look at some of these forks. So Daniel Stenberg, the creator and maintainer of curl, which is, by the way, also commercially supported by wolfSSL, he created this diagram in his recent Family of Forks blog. So you can see here the legacy code and modifications. wolfSSL, on the other hand, has no external dependencies. It's not imported. It's not a fork inheriting legacy code. It's had a couple of name changes over the years, but otherwise wolfSSL has been developed in a clean room implementation independently of others. This clean history makes commercial licensing clear. There's no ambiguity for wolfSSL customers. In fact, as Emma said, there's a lot of engineers at the company, and many of the original developers are still with the company. Okay, so back to performance. If you look at the vertical axis here, wolfSSL continues to scale linearly with the number of concurrent threads. The only other library performing better than wolfSSL is AWS, which, by the way, is not the best solution for embedded. Some of you may already be using OpenSL. For those situations, there's a compatibility layer that makes it easy to convert to wolfSSL. Back to the HA proxy article we were looking at, they also made some comparisons. Imagine needing to deploy 100 times as many machines just because of the underlying performance. wolfSSL is already in space, already in ground systems, already in rockets and delivery systems. Some customers prefer anonymity, and we respect that. But we can share our customer names such as Lockheed Martin, Northrop, Maxar, and the others shown here. wolfSSL is used by all branches of the US military, including the Space Force. So briefly, wolfSSL has many partners. You may recognize some of these companies. And these are just some of the open source partners. Okay, so now that we know a bit about wolfSSL, let's dig a bit deeper. wolfSSL can help with your threat model. And so the question to ask is, what threat model? Well, today I think we can all agree they're the largest attack surface ever for satellites. It's important to understand your threat model and exactly what it is that's being protected and what the expectations are from the mitigations. These days, the scope of adversaries is essentially unlimited. At some point in the past, the only real satellite adversary was the nation state. Today, the threat actors are as common as bike thieves. Here we see a U-lock mitigation that was, I suppose, technically successful. But what are some of the threats to satellite communications? It's important to ensure the right mitigations are in place. We need to understand not only the problem, but the realistic scope of the mitigation. So last year I gave a Hackaday presentation on installing custom firmware on commercial devices. It's easier than many people think, particularly with physical access. But how difficult is it for physical access to a satellite? How easy is it to replace firmware on a satellite? Remember the old James Bond movie where they captured a satellite in orbit? This technology is for that is closer every day. Perhaps it's already here. So can a motivated adversary capture a satellite, maybe even return it to Earth? Even worse, modify it and put it back into orbit? We need to assume that the answer is yes. And so then, are there keys stored in plain text? Private keys, perhaps? Today, even public keys could be vulnerable to post-quantum attacks. There are many open source and inexpensive tools available. This inexpensive open source Tiger JTAG debugger can be used to install completely different firmware. It can also read and even intercept data, including things like public certificates. This is an example of why physical protections also need to be implemented. The Tiger is available for only about $50 and is widely available. These days, anyone can communicate with satellites, and many do. A few years back, I myself pulled a full disk image of our planet from a GO satellite from my backyard. It's much, the receivers are inexpensive, and the software-defined radio, the SDR, makes them even more powerful. Receiving, that's the easy part. The phased array technology significantly changed the ability of the backyard bandit to be able to transmit to satellites. This technology cleverly exploits the ERP, that's the effective radiated power. Every doubling of the number of antennas gives 3 dB gain, and that's double the power. Normally that would be a challenging physical positioning exercise, but get each of those antennas computer controlled, and suddenly we have an impressively powerful focused transmitter that actually uses relatively little power. For those of you that are not developers, it's important to know how easy it is to inspect traffic. There are tools such as Wireshark that allow you to inspect and decode data. Here you see a TLS 1.3 Kyber key exchange on an embedded device. There's a microblog there with more details. So the threat model is presented as knowledge. There are things we can do to mitigate these risks. We have solutions today to secure both communications and devices. We can leverage secure, proven bootloaders. We'll take a closer look at wolfBoot later on. You can use wolfSSL with post-quantum cryptography. You need to focus on a layer defense. And most important, it's more important than ever, it's important to use standards-based cryptography. More than ever, it's critical to use open source cryptography over proprietary solutions. The proprietary solutions will simply never be tested as rigorously and will never be able to have the scrutiny as compared to open source solutions. Having many eyes on the source code is the best way to spot potential issues. So what are some of the protections available? Well, post-quantum cryptography. wolfSSL has had post-quantum solutions available for years. One of the questions that people may ask, when will post-quantum be really needed? Well, today. Earlier we saw the CNSA timeline. There's an NSA mandate that we start migrating to post-quantum this year in 2025. So let's talk about this for a moment. Why is it that we want to use post-quantum algorithms? I mean, those computers don't even exist today. Well, what if they do, or now, or sometime in the near future? And so that you need to ask yourself, what does that mean for your data? And it shouldn't matter. There are solutions today to help mitigate this risk. So quantum computers can solve certain problems, right? They don't speed up everything, but one of the problems that they're really good at solving is factoring. In particular, factoring the product of two large prime numbers, which, as it turns out, is the core of how RSA works. And so once a private key can be derived from the public key, everything that used that private key is now compromised. What might look like random noise to a conventional computer, a quantum computer will, if you will, wiggle the data so that the answer falls out vastly more quickly than a classic brute force attempt. Some clever mathematicians created new algorithms that are not easily solved by a quantum computer. For example, the ML-Chem. Remember, quantum computers are only expected to be able to solve certain kinds of problems. The post-quantum computer should not be a fear. There's no need to speculate. There are validated post-quantum safe algorithms available today. PQ algorithms should be the default on all new systems. For the developers in the audience, post-quantum is super easy to use in wolfSSL libraries. You have your own secure sockets layer connection you see here. The TLS 1.3 post-quantum key share is easily configured with one line of code for wolfSSL. Included in the microblog that I mentioned earlier is this screen snip showing just how easy it is to enable the Kyber key exchange. Of course, that was prior to it being renamed to ML-Chem. We'll be talking more about post-quantum later on. So I mentioned the Hackaday presentation earlier, which focused on e-waste and how existing satellites could be repurposed. How existing devices could be repurposed. But what about satellites with devices that are orders of magnitude more complex, sensitive, and expensive? There are limited options available. One cannot easily dispose of an orbiting satellite. I mean, what do? There's no space dumpster. So let's plan to ensure that that's not a major concern. With wolfSSL, we can easily swap in new algorithms that are more robust and more secure, extending the life of your satellite. One of the solutions available is post-quantum cryptography, of course, as we mentioned. For satellite systems, performance is key. It's one thing to say you have post-quantum, and then assuming it's properly implemented, the next logical question is, how fast is it? We saw this slide earlier. Remember, wolfSSL is the orange line on this graph created by HA proxy. The only one faster is AWS, and let's remember that's not a great solution for embedded. So we already know that wolfSSL is the best choice for embedded, but what about post-quantum? So here we see the performance of MLDSA. We see it's on par for signatures. Here comparing MLDSA to ECDSA. The difference is in fractions of milliseconds. And if those fractions of a milliseconds matter, there are a variety of configuration options that can be used to performance. The wolfSSL key exchange is much faster for post-quantum. Here we see just how much faster when comparing ML-Chem in dark blue to ECDH, notably slower in light blue. There are two main wolfCrypt examples, the test and benchmark apps. Here we see the command line running a sample. Both the test and benchmark apps are available on all the different target hardware platforms. But let's continue the discussion on compliance, and let's take a look at the infrastructure for upgrades such as bootloaders. One of the solutions available is wolfBoot. This is an open source bootloader to ensure firmware integrity and authenticity. I gave a presentation earlier this year at CISAT conference in Paris. Check out this video that goes into much more detail regarding wolfBoot. We saw in a previous slide that wolfSSL is fully implemented and supported ML-Chem for key exchange and ML-DSA for digital signatures. One of the questions that came up for me at the CISAT was the status of Falcon and HQC. I was a little surprised at the interest since neither of these are NIST approved. We did, however, have Falcon support way back in 2021, but as it was not NIST approved, it didn't gain much traction. The same with HQC. This too is not yet NIST approved, but maybe you want to use it anyhow, perhaps in anticipation of approval. We're ready. But back to wolfBoot, some of the devices have no secure bootloader. You just load the code and run. Some companies have their own proprietary secure boot processes. wolfSSL follows the best practices in RFC 9019, and it's all open source. Here with conventional cryptography, a private key is used to sign the firmware. In green, the bootloader runs. This is where the embedded system image is validated with a public key. We already saw that if a public key is stored in plain text, as has often been the case, it is vulnerable to a post-quantum attack. Let's take a look at some solutions that protect those public keys. One of the key aspects of any secure bootloader is the trust anchor. The important part of the trust anchor is to ensure the public key is available and not altered. RFC 6024 goes into detail as to what that means. For our purposes, this just means that wolfSSL is following well-established industry best practices. And it's all open source. There's nothing proprietary, and it's all on GitHub. Note that even using a trust anchor, physical security is still everything. It's not out of the realm of possibilities that an adversary captures your satellite. We should view the James Bond Spectre film from the 1960s a bit differently these days. Every possible measure should be taken to ensure physical protections. So the question to ask, would you trust your satellite to be deployed to a vineyard? Is it physically secure, even though currently deployed far from Earth? Beyond unauthorized insertion, deletion, and modification, we now know that even accessing a public key has risks. wolfSSL supports a variety of trust anchor stores such as TPM, OTP, HSM, and more. We'll see more about that in a bit. wolfSSL also supports the out-of-band trusted provisioning authority. The key store is a critical component of any firmware signing implementation. Here we see the various possible options available for wolfBoot, including wolfTPM and wolfHSM. The important thing to note is the key store API makes it easy to upgrade or change the actual physical implementation. You might start with write-protected flash and later upgrade to a TPM. Relatively little source code would need to be changed. Perhaps over time there's an upgrade to a TPM module. With the key store API abstraction, a new TPM can be easily swapped in. wolfBoot leverages existing deployment by using a combination of both conventional cryptographic algorithms as well as post-quantum. Here you see that wolfBoot supports hybrid authentication. This is basically the best of both worlds, using both conventional and post-quantum. And remember, it's all open source and already widely used. The software is exhaustively tested both internally as well as by international researchers. So one of the wolfSSL engineers, Daniele, put together an excellent webinar earlier this year about getting started with wolfBoot. You can check out the recording here on YouTube. Next, we'll take a look at wolfTPM that we mentioned earlier. So wolfTPM is another open source solution available on GitHub. It's a portable, open source TPM 2.0 stack with backward API compatibility. It's designed for embedded use, highly portable, and has native support for Linux and Windows. RTOS and bare metal environments can take advantage of a single I/O callback for the SPI hardware interface. There's no external dependencies, and the code is compact with low resource usage. So TPMs store cryptographic keys in tamper-resistant hardware. Private keys never leave the TPM, preventing extraction even if the OS is compromised. This makes man-in-the-middle attacks or key theft attacks much more difficult. TPMs can conform operations like RSA, ECC, and hashing internally. This ensures sensitive operations such as TLS handshakes and digital signatures are done securely without exposing key material to system memory. TPMs can also generate and store unique device identifiers. These are the EKs or the endorsement keys. They support remote attestation, proving to a remote server that the device is running authorized software before communication is allowed. wolfTPM, like all of the wolfSSL source code, is all open source. Here we see the HAL directory, the hardware abstraction layer for TPM devices from many different manufacturers. This allows developers to easily swap in replacement devices with relatively little change to code. One of the common questions I received at SciSat was whether I knew about any rad-hard TPM devices. I'm still not aware of any TPM modules that are fully radiation hardened, but there are some things to make existing devices radiation tolerant, as seen here. So a firmware TPM, you can run something in the trust zone. There's a rad-hard FPGA, for instance, the Xilinx FPGA microblade. Now, TPM is a big topic, and we could spend all day talking about it. If you'd like to learn more about TPM, check out this excellent video recording of David's presentation. He's the primary author of wolfTPM. So far, we've looked at the core wolfSSL library, the one that's used for the communications layer. We saw the core cryptographic algorithm library is wolfcrypt. There's the wolfBoot product for ensuring firmware authenticity and how it can use the wolfTPM library as a trust anchor. Now we'll briefly look at some additional libraries that are often used by our customers. One is wolfSSH, which provides a secure way to access and control remote computers over an unsecured network. SSH is a protocol like TLS, but is typically used for a remote login. In short, wolfSSL is a small, fast, portable SSH implementation, including support for SCP and SFTP. Like all wolfSSL solutions, the code is all open source and available on GitHub for you to download and test drive. So this is an example. This is a project inspired from my early network admin days. I remember walking around with a laptop and a serial cable to plug into each of the routers. This project takes an inexpensive ESP32 device in the M5 stack package device here, something called the M5 stick, and it adds a remote UART login capability over SSH. So you see the physical connection there on the PC board, which normally would be a UART, and now you can connect to that over Wi-Fi using SSH. The SSH embedded project also works on the ESP8266, in this case the Adafruit Who's a Feather. Note there's no cryptographic hardware acceleration on the ESP8266. The processor is a mere 160 megahertz max, and the maximum programmable space accessible in the heap and data section is around 50K. So we see that wolfSSH can be used with an impressively tiny footprint with very limited resources. Another one of the wolfSSL products is the wolfMQTT library. This is the message queuing telemetry transport. That's a lightweight publish subscribe network protocol. This is typically a good solution for low bandwidth, high latency, or unreliable networks. wolfMQTT, again, open source, available on GitHub with a variety of examples. Eric has an awesome Getting Started with Secure MQTT. You can see the YouTube video link as shown here. So before we wrap up, I want to share a brief summary of some of the other solutions available. So we see Wolf Provider, Wolf Engine, and Wolf HSM that may be of interest to you. So Wolf Engine is an open SSL engine backed by wolfSSL's wolfcrypt cryptographic library. wolfcrypt is FIPS validated, so Wolf Engine can be used to achieve FIPS compliance with OpenSSL, all without having to touch the OpenSSL code itself. The quote-unquote engine is typically used with older versions of OpenSSL. This allows wolfSSL to plug to plug in updated cryptographic providers without needing to upgrade the OpenSSL itself. Wolf Provider, on the other hand, is for newer versions of OpenSSL upgrades, including FIPS 140-3 certification. Introduced in OpenSSL 3.0, the provider architecture allows cryptographic functionality to be separated into loadable modules. This allows our customers to use wolfSSL libraries, again, without needing to rewrite all of the OpenSSL specific source code. Similar in concept, I suppose, to a TPM, but much higher performance and more feature-rich is an HSM module. This is a hardware security module, a physical device used in cryptography to securely generate, store, and manage cryptographic keys. It's designed to resist tampering and unauthorized access, ensuring that sensitive operations like encryption, decryption, digital signing, key management, and more are all performed in a trusted environment. The Wolf HSM can also be used as a trust anchor, as we saw earlier with wolfBoot. So one of the useful features of Wolf HSM is it can manage state. This is particularly helpful, for instance, when using stateful post-quantum, such as LMS and XMSS. Okay, so now that we know all about wolfSSL, we want to talk about how to get started. Well, the Raspberry Pi makes an excellent text device. It might be particularly helpful to Windows developers that may have a Windows firewall and even antivirus software interfering. The newest Raspberry Pi 5 even adds support for SSD drives, as seen here. You can see the steps needed to download and build wolfSSL. Here we are just using the blanket enable all to turn everything on. Typically, a command line build will pass additional parameters for other features and performance modifications. The prior make command should have built both the client and server examples. Here you see a typical server listening in a loop. Commented out is an example that forces a specific cipher suite. The example TLS server can give informative message about the client connection that's seen here. For embedded applications, the user settings file is used for configuration. You can think of this as the place where all the knobs and dials exist to select features and fine-tune the library. There are some sample configs here in the examples config directory. And here we see how the user settings is loaded in an application file. Note that the user settings file is implicitly included when you include settings.h, and you should never explicitly include it. You should always load the wolfSSL includes after the settings.h. This is super important. You can save yourself a lot of grief by remembering this key rule. Again, you never include the user settings explicitly, and you always include settings.h before any other wolfSSL. For more details, not only are there code examples on GitHub, but also a variety of getting started videos on the wolfSSL YouTube channel. So let's take a look at what we covered. We've seen many of the different wolfSSL products available, all of which are open source and available on GitHub. We reviewed some of the key wolfSSL products and saw how the core wolfcrypt library is used in all of them. There are libraries for TPM, HSM, SSH, MQTT, as well as language wrappers. We briefly discussed how wolfSSL is available for all mainstream development environments, including Arduino, to help you get started quickly. wolfSSL has examples for all these environments. If your environment is not listed here, let us know, because we're always looking for new ones. For Visual Studio users, the project files are in the root of the repository, as well as the Win directory seen here. For Windows users, there's also wrappers available for C# projects. We saw how wolfSSL is a leader in performance. Remember, the only library that scales better than wolfSSL is AWS, and that's not a great solution for embedded or other small footprint environments. We talked about the importance of FIPS certification, and even if you don't need it today, it's great to know that you could get this certification at some point in the future if needed. So wolfSSL has engineers all over the world available for 24/7 commercial support, and we also offer consulting and integration services. So wolfSSL is the leader in space cryptographic solutions, already in service in satellites, payloads, ground stations, rocket delivery systems, and space stations. So thanks everyone for attending. Thanks also not only to all the wolfSSL staff, but I'd like to in particular thank all the folks in the community and the university researchers that have helped make wolfSSL the best cryptographic solution in the world. So if you have any questions, feel free to enter them in the chat. There's also an option to send the question only to the moderator if you prefer anonymity.
Thank you, Jim. We're going to dive right into the questions. What TPM support is out there for post-quantum exchanges?
Oh, you should be able to do, let's see, well, you don't really do an exchange in the TPM, right? The TPM is typically used to store things. So if you want to have a follow-up to that question as to what you mean by an exchange, but Anthony,
Jim?
yeah, go ahead,
Yeah,
Anthony.
this is Anthony. So, currently, TPM, well, okay, the current standard is TPM 2.0, and that's maintained by the TCG. There has been discussions and new drafts specifying support for post-quantum algorithms, but those are not yet publicly released. And and technically speaking, we're not a part of the TCG yet, and so we don't have access to those, but we do have friends in there, and we do know that discussions are happening. So, please stay tuned. We'll probably be blogging about this very, very soon.
Perfect. Does CNSA 2.0 define key sizes for post-quantum values? And do you have any recommendations for key sizes in space?
That is a great question. So, when you look at the post-quantum algorithm parameter set names, let's take MLDSA and MLChem, for example. MLChem, their parameter set names are 512, 768, and 1024. And those specify a strength. That is to say, a post-quantum algorithm strength. And obviously the strength does affect the key size. So each of those strengths have associated keys, public key sizes, private key sizes, and ciphertext sizes. Notably, the shared secret that comes out of them are all 32 bytes. For MLDSA, the names are MLDSA 44, 65, and 87. Now, those numbers seem a little weird and outlandish, but those numbers actually specify the dimensions of a matrix that are used within the calculations of these algorithms. And again, these do specify the strength. So each of the strengths have different public key sizes, private key sizes, and signature sizes. But they all accept the same sized, they all sign messages of any size that you wish to sign. So yeah, the key sizes are specified, and you can look on in our documentation to find out what those key sizes are. They are notably larger than ECC. Thank you.
Wonderful. I see a few of you have your hands raised. Please just type your questions into the Q&A box and we will get to them in order. Spacecom's links are often simplex. That is that is why we command in the blind and do telemetry contacts that don't have an uplink. Isn't SSL and PKI full duplex?
The
Yeah, Anthony, I'll
simplex.
let you have that one.
I'm actually not familiar with the terminology, but I'm going to assume that simplex means that it's one way, whereas duplex means that there's two-way communication. And so if there is not two-way communication, then that is correct. You're going to have a very difficult time doing TLS because, for example,
They just said simplex is one way, so you're correct in that hunch.
okay, that makes sense then. So in that sense, you're going to have a real hard time doing TLS. But like if you have a pre-shared key, for example, then you could just then you could just send encrypted AES packet.
And then how would that apply to space? Anthony? Did we lose?
Might have lost Anthony. I see him still connected.
Seems like we might have lost him.
Oh, I'm
Um,
back. My
oh,
apologies. My connection seems to be not stable.
no, you're good. I wasn't sure if I got lost somewhere in there.
Oh, what was the last thing you heard me say in my last answer?
Um,
Yeah, Anthony, we heard everything you said. There was a new question regarding how does this apply to space, right? Was
How
the
does
last
and then
question from
they
Emma.
and then they said that it doesn't. So
Okay.
I'm not quite sure. Okay, the next question. The TCG will be releasing the specification that includes PQC this fall. Seal SQ will be sampling PQC capable TPMs by the end of 2025. It's more of a comment than it is a question.
Yes. Thank you. Thank you very much for that clarification.
Okay. Is the ARM trust zone supported for wolfBoot?
Oh yeah, so a non-post-quantum question, I can certainly answer that. Yeah, I kind of glossed over some of the details when discussing wolfBoot. It's a great question, and the answer is yes. So wolfBoot manages the secure domain in the trust zone M on, like, for instance, what is it, the ARM V8M architecture.
Is the Infineon SLB 9672 TPM supported?
Oh yeah, I kind of glossed over some of the specifics on TPM as well. There are several different TPM devices from Infineon. I don't recall the specific part numbers, but you can check out the GitHub page. It's probably listed there. All of the mainstream Infineon chips I think are supported. Yeah, there's also support for Microchip, ST Micro, and others. But if you
Oh,
have a TPM that's not listed, go ahead, Anthony.
I'll also add that we have a product page. It lists lots of them. I believe the one that was asked about specifically is supported. So
Oh
go
yeah,
ahead and
cool.
yeah, go ahead and download wolfTPM and give it a whirl.
Um, are the Delta updates supported for wolfBoot?
Yeah, so that's an important question, and yeah, that's one of the key features of wolfBoot, in fact. So if you have yeah, a small amount of bandwidth and you want to update just maybe a submodule of the software that's running, where, or even more likely, you want to deploy new keys or something. So there are deltas that can be sent with wolfBoot. Yes.
Wonderful. Another TPM question. Is wolfTPM available for Arduino? I don't know how to say
Oh yeah, Arduino.
that. They're interested in evaluating it.
It could be. Recently, I put together a manual install for the TPM for Arduino. The Arduino libraries require a kind of a special code and structure, if you will. So yeah, so when we publish wolfSSL for Arduino, we have to copy things to a different repository for it to get published to the Arduino library. Um, the answer is yes, it works. No, we don't yet have something to publish that on a regular basis. So if that's something that you're interested in, definitely send us a message and we can prioritize automating that.
Wonderful. I think this is the last question. What are some of the concerns in the satellite industry that we should have around crypto agility?
Maybe I can
that's a
tackle
yeah,
that
that's a good
one.
question. Go for it, Anthony.
Yeah, so the satellite industry, one of the things about them is that, satellites are generally rad hardened. And then they're also in remote locations, right? So space is a fairly remote location. Um, so quite often people think of them as fire and forget. We're going to launch this into the air and it's not going to come back and it's just going to work up there. No one's going to touch it. And the reality is that, it is that we still are we are in a transition period right now between going from conventional cryptography to post-quantum algorithms, and it requires crypto agility. Now, this, if you think about crypto agility, this agility is just a kind of, how shall we say it? It's just one of the other trade-offs that you have in the embedded world, right? So normally in secure applications, the trade-offs are uh, performance, memory usage, binary image footprint. And now you have a new one, which is your crypto agility. So if you're willing to trade off any of those other things for crypto agility, then then you're in luck. It's really easy. It's really simple. But if you're not, then what we have in store for you is this thing that we call build time crypto agility, where you use wolfBoot to allow you to swap in and out new firmware. And so when you do build time crypto agility, you start off supporting the conventional algorithms, for example, and then you don't have any support within your firmware for post-quantum algorithms. As time progresses, as the focus to post-quantum algorithms becomes stronger and stronger, then you might want to, exercise that agility and bring in your post-quantum algorithms. At that point, you can flash your device with with a with a new firmware image using wolfBoot, and that new firmware image will have only the post-quantum algorithm in there, and no longer have the conventional algorithms such as ECDSA or RSA. In that case, you didn't need to sacrifice for example, binary image footprint size by having implementations of multiple algorithms. I hope that was a helpful answer.
Sounded good to me. There was another question that came in. Has wolfSSL been used with OPT before?
I'm gonna throw that back to Jim.
Yeah, I didn't know the answer to that either. So I had to Google. It looks like we did have a blog about that a few years back, but I don't personally have experience with it.
Let's
Wonder.
see. Give me a second here. Yeah, I don't know too much about. I don't see any references to it in our source code either.
Might be a good question to send to support if you're interested. Sorry about that. I'm sure somebody at wolfSSL knows.
Yep. Or support or fax at wolfSSL.com.
Wonderful. Well, thank you, Jim and Anthony, for hosting an informative webinar. Oh, another question just came in. Is there any practice about wolfSSL and satellite communication?
Practice.
Okay, well, first I see the OPT. I guess thanks for the clarification that was apparently covered in the trust zone. And Anthony, there was a question regarding the wolfSSL, the practice about wolfSSL, and I'm sorry, I guess I don't really understand the question.
Yeah, I don't know how to interpret that.
So
So
if the
is there any kind of if you're asking if there's any current use case where wolfSSL is in space, I think the answer is definitely yes. We can definitely let you know that wolfSSL is in satellites, it's in ground systems, and it is used very, very widely within the space industry. We've gone within the presentation, and the slides will be available upon request, but you can see some of the company names and logos of the companies that we've cooperated. Also, military and space or government organizations that we've coordinated and cooperated with.
Wonderful.
So I'd like to point out, if you did miss those company names and logos, feel free to email fax@wolfSSL.com to request our slides.
Perfect. Thank you guys again. Thank you to everyone for joining. I will email a copy of the webinar recording. You can keep up with our upcoming events, meet our team in person, read our blog posts, and get the latest wolfSSL updates by following us on X, connecting with us on LinkedIn, and subscribing to our YouTube channel. If you have any questions, please reach out to us at fax@wolfSSL.com. Thank you again, and we look forward to seeing you on July 31st for our webinar in the APAC time zone all about automotive. Thank you all.